All right, hello. Welcome to Data-Driven Security at Tableau. Really excited to see so many people into both data and security, so we're going to have a heck of a good time. So the plan for today is to give you a really loud microphone, as well as not one but two security talks. So the first one is going to be me, and I'm going to be giving you an overview of how we use data to inform and drive our security program at Tableau. And then I'm going to hand it off to my esteemed colleague, Jason, who is going to be taking you through a deep dive really into answering one particular question with data. And he's going to take you through how we got the data and wrangled it and visualized it and then eventually learned from it. So first up, a little bit about me. My name is Braxton. I've been on Tableau's security team for the past 2 years. My past lives include being a small business sysadmin, doing security consulting for the federal government. I've been a security engineer for one of the largest cloud providers on the planet. And for the past 2 years, I've been taking on some of the technical and operational security work at Tableau. Basically, if it lights up and has security implications, it's in my world. So I am also the co-host of a security-focused podcast called the Sound Security Podcast, trying to help defenders in companies and otherwise be a little bit better at defending their information. Last but not least, I really love biking and also making things way too hard on myself. So last year, there's an annual bike ride that bikes from Seattle down to Portland, which is a distance of a little over 200 miles. And I thought it'd be kind of fun to do not only that, but do it on my trusty single speed that I've had since college. I lived to tell the tale. The jury's still out on whether it added to or took years off my life, but it was a lot of fun. It was a beautiful ride. So to kind of set the stage on the overview that we're going to take on, I really wanted to kind of explain some of the motivations behind doing this talk to begin with. So the first motivation is really wanting to be able to package up and share what we've been learning on Tableau's security team over the past number of years as we try to better integrate data into our processes and our decision making and how we evaluate the work that we do. The second motivation is really to meet all of you, to start a conversation with the people that are really interested in nerding out on data and security. Because I look at my title and I see that there's this word engineering in it, engineer, and I think our industry has come a long way, but I think there's still a lot of work left to go as far as making the decisions that we make a lot more repeatable and discrete and known, so that we'd kind of be able to express the risk tolerance of a web application the same way a civil engineer knows how many cars go across a bridge without the thing collapsing. So that's kind of the goal, is to really to share what we've learned and then start the conversation with you all, and really looking forward to both of those. So in digging into the next slide. So really admitting it is the first step. So I want to say that this is something that we're in the process of learning. A lot of our work is, over the past couple of years, has been spent finding the right data that we need and getting it in a sustainable, scalable, repeatable way, and then using that to visualize it. So this really is a process. I want us all to learn together. Singing Kumbaya is optional, but it can be fun, so feel free. So the working definition that we'll be using for this talk is really that we use data at Tableau, and particularly in the security program, to really make, answer questions about our security program, gauge success, and help prioritize the risks that we see in our world. So it kind of makes sense for me to start at the very top, and that really is answering the question, are we more secure? Is our program better off today than it was the day before, the month before? Really knowing if we're making a dent. So to do that, we need some data, shocker. We're going to be pulling on a list of tasks that we've been working on. So we're going to go talk to our project management tool that lists out all the things that we've been working on. But more than just that, we need to know where that work is going. So in order to kind of bucket it up into different program areas, what we're doing is we're using one of a million different frameworks for structuring a security program. We're roughly basing ours off of ISO 27001 program, but you could just as easily use NIST or COBIT or PCI or any of the frameworks that are out there. In addition to that, we want to know not only what the work is, where it's going, but how much better off we are having done it. So to do that, we're bringing in something called the capability maturity model. For those of you that are still awake after having heard that phrase, what that basically is a way of structuring and knowing how mature a given process is on a scale of 1 to 5. 1 being, this is the first time we've ever done this. It takes the heroic efforts of some guy staying up till midnight, burning the midnight oil, coming in right at the buzzer to get this task done, all the way up through 5, which is, this is a known task. This is something we've done before. It's documented. More than one person can do it. And we're collecting metrics and regularly reviewing it to make it even better. So you combine all those things, and you come up with this viz that we're working on, which shows us at a snapshot, at a glance, the maturity of our security program. So at the very top, you got the rough program areas, or the overall program areas that we're building off of, and our various maturities in that area. All the data you're going to see here is fake or anonymized. Security engineer at heart, couldn't get away without that. But it gives you a rough idea of both where you're at overall and the projects that you've taken on that have gotten you to those various levels. So that's all well and good, but what I really like is that we're able to then use this little time slider to rewind the clock and go back in time and see when we were a wee little security program where we were at. So right now you can see that IT policy and compliance management was the first thing to go. Being a publicly traded company and wanting to continue being able to sell this awesome software that we make, kind of makes sense to make the folks behind the Sarbanes-Oxley Act happy, so we can be publicly traded, as well as a little bit of security operations. Then you can continue snapshots and see really how we're growing over time and really maturing our program. And not only that, but then we can rock out and look into the future and see, if we continue doing the work that we're doing, this is where we think we'll end up, this is where we think we'll land, and have discussions around, is that where we want to be, or are there other areas that we could be focusing on? So additionally, we're using data to really help inform and drive our compliance program. There is a number of tasks that we have to do for the various frameworks that we're under. So the key question is really, are those regular reviews on track? There are a stack of tasks that we have to take on every quarter or every 6 months, depending on the framework, that says go review this system and make sure we have backups in place and the right access for the right users, and so on and so forth. So there's this ability for the task to start and then fractal out into a whole bunch of other tickets that we have to follow up. So we want the things that need follow-up to be big and red and flashing and angry and waiting for us, and so they don't get missed. So the data to do that, again, comes from our vulnerability management tool, or not our vulnerability management tool, our project management tool, lots of management, in which we're grabbing just the overall review tasks, doing a little parent-child relationship so we can show this task led to the other one. And because any of you who have done any amount of data munging will attest, there is not always the ability to put the perfect data in the right perfect place. So we're just, we're taking the title for the tickets and we're adding a little bit of a naming convention so we can pull out where in the process each of these things are. So all that leads us to an all-out view of the various tasks that we're taking on. So say we know we have to take on a data center access review for a particular quarter, and that led to a follow-up ticket with one of the teams and able to track status that way. But additionally, what that gives us is the ability to look at, for any given quarter, where we're at. So we know that the tasks that are considered under pending our team's review, we need to focus on and get out the door, as well as the things that aren't assigned currently. I need to make sure that all of us have owners, and we get a really nice snapshot of exactly where we're at in the process and what things are left to be done. Next up in the compliance side of things, if any of you have ever had the pleasure of trying to manage and maintain Salesforce permissions, my condolences. It is a very, very complex world. To give you an idea of what all that entails, you have the idea of users in Salesforce. So far, so good. But then on top of that, you add profiles, which is a grouping of permissions that user can do. And on top of that, you then have permission sets, which override profiles. And then yet on top of that, you have these concept of roles, which are kind of like row-level filtering in Tableau, which dictates what actions a person can do on which objects. So a sales area manager can manage and access sales-related data only for, say, Seattle versus the whole world. So all of that is about as confusing and complex as you might imagine. It ends up being around 14,000 individual checks that we have to make sure are in place, and it leads to a whole large amount of management pain. So what we're doing is we're using data and Tableau to help solve that, to help make that known and easy. So what we're doing is we're doing a regular extract of the current state of data in Salesforce, and then every quarter we do a baseline, having done the review for the previous quarter. And by doing that, we know what the known good actual state of permissions in Salesforce should be. And then comparing that with a little bit of Excel mangling and some Tableau magic, we're able to get a worksheet that should always be, in a perfect world, blank. There should be nothing on there because that's a list of all the permissions, issues, and mismatches in the system. So we could do that. We could just have a worksheet out on Tableau server that tells us that there are no issues or there are issues with permissions. But we want to get notified as soon as there is a change in that dashboard. So to do that, we're using a tool that was developed internally and has been open sourced for around a year now by one of our principal engineers on our Tableau server team. And what this does is it's called Viz Alerts, and it gives you the ability to get automatically notified when a worksheet or a dashboard changes. So by pairing that worksheet that should always ever be blank with a little bit of notifications, we get these nice email-based alerts that give us an export of the data involved, the user, the profile they should have, and where the permissions fell down. So it takes this very complex and difficult process and boils it down to, go look at that. That one is wrong. So that's pretty handy. Additionally, we are always trying to be cognizant of the impact of additional security layers and capabilities that we add to systems in our environment. Anytime you add a new security capability, there's the opportunity for a hit to usability. It's kind of this yin and yang thing in the security world. If you give me a server and you tell me to secure it, I'm going to dig a 6-foot hole, put the server in the bottom of it, cover it in cement, and call it good. Obviously, that's a secure server, but it's not the most usable server. So what we're trying to do is really gauge and make sure that the new security capabilities that we want to roll out to the systems in our environment is tolerable, is something that can be sustained by our users and isn't going to hinder the business and folks doing what they need to do. So one particular case where we wanted to evaluate the impact of a security control was in looking at applying full disk encryption to developer desktops. So these are the machines where Tableau source code is written and is downloaded and is updated, and where local compiles happen of our software. So we really wanted to make sure that nobody that was able to walk into our office could walk out with a big handful of our intellectual property. That seems pretty much in our wheelhouse. So we ran a couple tests across a couple different encryption technologies, and we would take a developer desktop that was unencrypted. We would load Tableau source code on it, run a compile job, and get data around each step of the process. And then we'd encrypt that same desktop, do the same job again, and plot out the differences. And what that led to was a handy dandy dashboard like this. And what that gives us is a really nice all-up view of the cost of applying this extra bit of security. So this is, again, kind of faked up and simplified data, but what it gives you is an idea of us being able to go to our development leadership and say, all right, we think it's a good idea. We think that the risk of desktop being, walking out of the office is real and could happen. And we think that taking a 7% hit for compile times is a reasonable trade-off. What do you think? We can have that conversation and do it based on data. You can also dig in and look at, for a particular build step, some of these are like, that's mostly the same, I don't really care. And come down here to step 11, you're like, oh wow, that's a lot different. Is this something where it really needs heavy I/O, needs to get files off the disk really fast? Are there ways we can optimize that or choose a different encryption technology to make it a little bit faster? So in the end, with that process, we were able to successfully sell the idea of doing full disk encryption and do it using data, which is pretty fun. So next up, we're going to talk a little bit about data's role in vulnerability management, or the much more fun title, Reducing Risk with Science. So the question we're trying to get at here is really, which of our applications are the riskiest? Which of them bear the most risk? So to do that, we've got vulnerability scanners that are deployed throughout the company, both internally and externally, automatedly looking for security vulnerabilities over time and reporting those back to us. But additionally, we don't just want to report on like the vulnerabilities with a particular server because it's contextual. There may be a server that is hosting HR data that has all of the company's social security numbers on it, and there's another server that is just hosting a team intranet site or tools site. And the same vulnerability on one host is going to matter a whole lot more than the same vulnerability on just a team testing host. So what we're doing is we're taking a collection of little Ruby scripts that I wrote to do horrible, horrible things to the APIs of our vulnerability scanners to extract all that data and toss it into a reporting database. And then we're building out an application inventory, tracking really two key pieces of information for each application. And that's what data is stored on the application. So we have a data classification policy that ranks data from public, which is things you could download off of www.tableau.com, all the way up through nuclear, which is source code and customer data and very highly critical data that we store. We also have the application's deployment within the network, so we know whether it's internet facing or internet facing with IP restrictions, or whether it's deployed internally and internally with restrictions. And taking those things together, we can use those as multipliers to say a vulnerability in a vacuum is this level of severity, but with the contextual information from the application, it's now a higher severity. So having grabbed all of that data, what that gives us is a really nice overview, and this is more of an operational dashboard that we'll use to make sure that the scans are progressing like we expect them to. So this is just a Gantt chart showing scans over time, and down below you can see this particular scan and its results in context. So this is a handy dashboard that we've got to represent to our teams the scans that are happening over time and the vulnerabilities that are being found. And then for some of these sites in particular, you can click and see a link directly to the vulnerability scanning tool that ran that scan. But even more interestingly is the ability to take that application list and the vulnerabilities we know exist on it and present that in a ranked order to the teams that own it. So you can select the team name over on the side, and via the magic of row level filtering, you can have a user who's a sysadmin on a corporate IT team log in, and they'll only see the applications that they own and that they manage. And then you can link over, having seen a little bit of metadata, you can link directly into a dashboard summarizing the risks that are coming to that application. So what it gives us is a really nice visual way to help teams prioritize. So if you were the owner of a system and you were wondering where to start in reducing the risks in your application, maybe start with the big angry ones in the top right of the screen. Gives you a good clue as to where to prioritize.
For the exploit, you mean exploiting the while of those vulnerabilities? So you're having a different data source versus that?
So we do a little bit of like threat intelligence. What this is mostly plotting is just the raw count of vulnerabilities plotted with the risk score of it. The risk score is a combination of how accessible it is and how exploitable it is, and that kind of thing. CVSS for those of you out there. We can also plot and get an idea of the number of exploits and the distribution across the different hosts that make up the application. And this is also particularly helpful for getting a sense of how evenly distributed and well managed the systems are, particularly for a system like this, where you'd want all of the systems to be configured pretty much identically and interchangeably, seeing that there's differences in this tree map for when one server is bearing most of the risk for it. It's a good chance to go back and look at your configuration management tool and make sure that you're actually getting things deployed in a level way. And then you get some information as well for the system owners that can get an idea of where their application is and what data it's held and how those scores come to be. So next up, we're going to talk a little bit about incident response and how data is helping us there. So the question we're really after is how are we prioritizing the operational work that's coming to us? So any security team is going to have a stable of work that they're going to have to take on that is a workstation gets compromised and you have to deal with the re-imaging and the follow-up and the forensic review of that, as well as questions that just come from users in your company that are wondering how to do things more securely, all the way through to security questionnaires that customers or potential customers might be sending your way. So we really want to make sure that we're prioritizing that work well and we're not losing sight of things that are in our world. So as far as data, it's that same ticket level extract information being exported into Tableau server. But what I think is the more important and the interesting part of this data is not what happens inside that ticketing system and where that goes, but it's really the time that we take outside of that to define what our SLAs are, what states a ticket should be in as it's worked. Should it go from assigned to in progress to on hold to complete, as well as knowing by priority what the SLA we expect to be for that. So that leads us to a viz that's been really handy for our team, which is literally just the state of the tickets in our queue and gives us an ability to go in and prioritize the tasks that we're taking on. So as an engineer on our on-call rotation, I'm trying to figure out where to go. I'm going to focus on these that have just barely fallen off the SLA train. And then this guy is teetering on the edge, so I want to grab him too. These, they're doing okay. They can hang out for a little bit. So it gives us a really nice point in time. And again, having defined what valid states are for the tickets and where they go, this gives us a good chance to identify tickets that are not in the right states. Similarly using Viz Alerts, we have detections in place for when antivirus detects malware on a system and then is not able to automatically clean it up. And so we have access to a reporting database vended from our antivirus tool, and that kicks off an alert to our help desk teams to go in and manually investigate a system that wasn't able to be cleaned up automatically. So that's been helpful for them to help triage these things. So last but not least, given all the fun that we just covered, I want to leave you with one bonus one, which is our team's kind of guerrilla tactic for starting a security awareness program that's not cheesy and lame. It doesn't involve horrible videos that people have to watch every 30 days. So what we're doing is we are just bragging about people that do good things for security across our company. So we're starting with an employee who responds to a phishing email and forwards it to us within like 10 seconds and then emails out to their whole team and says, hey, I found this thing, you should probably not click it or not open that thing. As well as developers who close out security bugs that they find before they even get released out to customers. So using that as a really good way to brag about them on a wiki page that we've in that's literally called Security Wall of Awesome. And additionally, to commemorate that, we give out these little wind-up robots that dance and have the statement Tableau security winning on them. A little something to commemorate that. And then, of course, it's Tableau, so we made a viz. So we can track who wins these robots over time by team, and it gives us a really quick sense of, we work more closely with our operational teams and our IT teams. So it makes sense just by selection bias that they would be getting a little bit more of these robots. But we want to share the love with the whole company, and so this gives us a really good view of, hey, maybe there's a team that we're not working with as closely that are doing good things that we could be following up with and helping out. So before I hand it off to Jason to dig into a particular viz, I'll leave you with a couple takeaways and my horribly drawn takeout box picture. So this is really, you can't visualize data you're not collecting, fairly straightforward, but a lot of the work, like I said, is not necessarily in collecting, or is not necessarily in just nerding out in Tableau and having a good time there. It's more about defining what data you want, knowing that ahead of time so you're not actively losing data, and then bringing it over in a scalable way. You also can't measure progress towards goals you haven't set. Again, fairly basics, but has been really good for us to think about, okay, we know this chart looks like this, we know this visualization looks like this, but what do we want it to look like? Where should it be, and what time should it look like that by? Last but not least, you can't solve this yourself. Share what you've learned with other people. There's simply too much going on for one team to be the entire masters of the whole security domain. When there are people in your industry and in your vertical that are interested in solving problems in an area that might benefit. So share what you've learned, both with people in your area, and come up and talk with us after. I'd love to hear what you've been working on. So with that, I'm going to hand it off to Jason, and thank you.
Well, diving right in, I'm the other half of the dynamic duo. My name's Jason Hernandez. I'm your friendly neighborhood corporate network architect. I do networks for a living. I do Tableau because they pay me really nicely and I'm really having a great time there. And it turns out we make some really cool tools to analyze log data of all things. Who would have thought it? This is who I am. I've been with Tableau about 5.5 years now. Been a network architect, director, similar thing for the last 20-some years. I realize I'm old when I'm putting this together. And I actually took a stint here at IBM in Austin for 10 years, from 1990 through 99. So it's kind of a homecoming. And it's really strange walking around downtown after 17 years going, I remember that building, but what's that? It's actually been really interesting to walk around. I am a CISSP. I am a security nerd as well. So like I say, my main focus is networks, but somewhere along the line, I realized I'd pay people to do what I was doing, which is keep people out of the infrastructure. All right, I'll get certified. And in my spare time, I drive fast cars poorly. I'm working on that, but at the moment now I can at least put my car sideways into a tree with grace and style. So really the big things out of here is what can you do with your log data? Turns out everybody has log data, but nobody knows what to do with it. So there's a big difference what we set out to learn, which we'll talk about, and all the other stuff we found out along the way, which actually turned out to be more interesting than the first data we were chasing. There are, when I'm talking about this stuff, we're millions of lines of data live on this laptop. It's actually going to be shared, anonymized and sanitized, of course, but it shows the power of Tableau to be able to process the data, manipulate the data, and show it. Some booby traps I found along the way, some of which cost me several sleepless nights trying to figure them out. And quite frankly, what's in it for you? You have questions, you want answers, here's a tool how to do it. So, like most really complicated projects, I start with just a really simple question. The InfoSec manager asked me, where are all our VPN connections coming from? Well, that seemed like a reasonable thing to answer. I don't know, let's go figure it out. Yeah, that took me about a man-month worth of work, famous last words. What I didn't know then, I didn't know Tableau. I took the fundamentals course 5 years ago, put the books on the shelf, and promptly proceeded to build Tableau's network. So I am not a Tableau genius by any stretch. The last databases I touched were DBase, and for those of you old enough to remember, Advanced Revelation. I'm definitely not a database guy. I used to be a sysadmin back in the early 90s. That'll tell you where I am. And then, oh, by the way, we get, this is the network, so you get IP addresses, you don't get location. How do you do something with that? Didn't know that either. Turns out I didn't know a lot of things. First, don't read the eye chart. Look at the colors only. This is one log entry of each type. So out of all the data, we have about 3.3 million authentications. These are successful VPN authentications. And each of those generates two identical configuration records, one from each of our redundant pair of firewalls. The big things of interest here are in particular the blue. You notice that's a nice big blob of unparsed data. Guess what you get to parse? I just want to show it up there just so you get an idea of what kind of data you're staring at. So talking versus data gathering, because this actually took a fair amount of work. Where are you going to get your logs from? Are you going to get it from Splunk? Are you going to get it from a SIM? Are you going to get it from a syslog? Is it even a flat file somewhere? Just like you said, if you don't have it, you can't visualize it. So you got to figure out where you're getting it from. The next thing is, my ID, Jay Hernandez. That's kind of an interesting bit of data. Jay Hernandez, network architect, works for so-and-so, lives in so-and-so, is based in office, whatever. That all of a sudden opens up a whole bunch more possibilities. So where do you get your user information from? Active Directory, Open LDAP, whatever happens to be your system of choice. But having that data turned out to be a bit more of a challenge than I expected, and it turned out to be really useful. And then, how do you turn an IP address into, it's here on the map. Turns out there's multiple purveyors of IP geolocation data, MaxMind, IP2 location, to name a couple. There's some stuff that's out there that's free that's not quite as good, but it's a great place to start. And it turns out you can put things on a map with some moderate degree of accuracy. It's not perfect. In fact, I'll show you a glitch in our data that is probably a geolocation error. but it gives you a pretty good idea. And then another one. I'm going to stop on the slide for a bit. Business risk. The data presented here, if it was presented unsanitized, would basically tell you where all our executives are going, what their travel schedule is, where they've been, and the whole company for travel everywhere. It would tell you where our salespeople have been. There's a lot of data in here that in and of itself might represent a business risk. So take that into consideration, especially when you're plowing through log files. There's that issue. Secondarily, you're going to have results of this. Some of the results might not be wanting to be public. You might only want certain people in your company to know about it and certainly don't want it out in the street accidentally. Again, pay attention. And then on the other side of that, this is going to show some results that may give you some risk analysis or discussions to have within your company. Such as things like you have travelers to uncomfortable countries. Say, I'll pick on China several times during this presentation because they're known to have some issues with things like the Great Firewall of China, hacking, a number of other things that make them an interesting place to work. I'm not saying it's bad, but you need to have policies and controls in place to make sure your business is safe to your policy, whatever that depends on for you. And of course, these are all the different things I could think of, and there's probably a lot more out there of things that happens if you don't do it right. And if you have questions, please see the appropriate departments in your company for help. They're there, that's what they get paid for, and they'll save you a lot of aggravation. Also, we will be hanging around afterwards, so if we're going too fast, you have questions, we'll be here to talk with you as long as you like, and when we get kicked out of here, we'll go to the hall and keep going. Not a problem. Data cleaning. I've got 15 months of data in here. I know some of it's missing, some of it's garbled, some of it's junk. Got to find it. We've changed the name of our firewalls during that time. Got to clean it, and so on and so on and so on. You have to analyze your data and know what it is you're looking at. You just can't take it as gospel. Dates and times. One big lesson, everything in UTC. Please, I cannot tell you how many times this tripped me up. Another set of sleepless nights. Times in your databases, make it UTC. Make sure it's represented that way. If your database doesn't do it natively, make it that way. That way you're not trying to figure out, is daylight saving times here versus daylight saving times in Singapore? What are the time zone offsets? Just that all goes away. Your data will be much better for it. And then keys. When I'm trying to merge the data, I start with things like a timestamp and a username would be a unique key. Yeah, not so much. So you actually need to figure out what your unique keys are in your data, so when you're trying to merge, sort, blend, you actually can match unique things to unique things. And it dives right into this. Again, merging and joining, you have to have those keys. IPv4 and v6 addresses. Tableau today doesn't handle IPv4 or v6 addresses except as strings. You get to do the conversion. v4 is not so bad. If you know how to do v6, please let me know. I'd like to know that one. And of course, data storage. I've got 3.4 million lines in MySQL here on my laptop. I guarantee there's a lot more data where that came from. Where do you store it? How much data do you have? That depends on your solution in the back end. But you got to take that into account. If you have 15 months of data at 2 gigs a day, that might be a little harder to do than if you have 100 lines a day. And lastly, along the range, what do you throw away when you're trying to do the analysis? What do you keep? What do you archive? What do you say, I don't need it anymore? If you try and keep everything, Tableau, quite frankly, runs really slowly, as well as your database, as well as everything else. You just don't have it. So this is what you are seeing. This is actually a Tableau storyboard. This is live data on the laptop. So if it's a little laggy between slides, you know why. So answer the first question, where do our VPN connections come from? There's your answer, everywhere. We are a global company. We have everything from Moscow to the capital of Uzbekistan, Tashkent. We have a lot of people all over Southeast Asia. And of course, all over, we have a very large presence in Brazil. And you can see it got to be a really interesting set of data. But one of the things I wanted to show was a time series of it, which I'm going to speed this one up and probably run it a couple times so it's actually easy to visualize. But this is by week, company growth and where the VPN connections are coming from. Faded dots are kind of the history, but you get the idea. I'm sure there's a number of different ways to represent this that are a little bit prettier, but I, quite frankly, ran out of time. But you can see the growth in things like China and Southeast Asia, Australia, South America. Another way of looking at your data. it'll get there eventually. All right, maybe it won't. So, of course, somebody asks, well, how many VPN connections a day are you getting? Here you go. This is 15 months of data that's been cleaned up all the way through almost the end of October of this year. The orange on the bottom represents what I would call countries of concern. They're, for our business, countries we would have a little elevated, pay attention to them for various security reasons, whether it be embargoes, sanctions, security risk, intellectual property risk, whatever is relevant to your business. And then the green is basically everything else. And as you can see, we got a lot of connections, got some really interesting spikes in there. But you can see almost by the day, by the week appearing in the data. But we want to take a look a little bit more, how does that break out? So we started staring at the data, break it out by unrestricted, the countries of concern, and then blocked. Blocked happen to be the 5 countries the US currently has full embargoes against. We have a little red glitch over there that actually was, according to our geolocation data, assigned to somewhere in Syria. It appears to be a problem with the data, because the geolocation data is not perfect for IP addressing. So I'm not in a panic over it, but it shows you that, oh, there was something we didn't know. There's a potential risk we had to go investigate. Your mileage may vary. If you look at the restricted ones, there's a glitch in the data. To this day, I can't tell you why. But it shows if you don't analyze your data, you're not going to be able to understand some of this stuff. And we've also got a very large pickup in the last couple of months, number of people making connections. It turns out there's a reason for that, but I'll share it at the very end. So one thing we want to look at, well, okay, where are the connections going by gateway? Translation, which machines are being hammered? It turns out the great majority of it's in North America, which is green, but a chunk of it's going to EMEA, which is in London, and APAC, which is in Singapore. But it varies all over the map. And one of the things we're going to be talking about here shortly is where they're coming from, and also why is it varying all the map? Turns out we have some bugs, and not in the data. So we said, okay, who's actually sending us connections? These are successful connections being made, so people are authenticating, getting in, and doing things. Warning, it is a log scale on the bottom, or else this would be a very hard chart to read. So it grows exponentially. Big surprise, United States, Singapore, Germany, where we have offices, do have a very high presence, but if you start to look, you see a number of the orange countries coming in here where we are getting connections from them, and we might want to pay a little more attention to them. But it also means we should be focusing our efforts for connectivity on the ones that are having the most connections, but also don't forget the bottom, because they're having problems from there. That's sales that get missed, that's work that doesn't get done, but it gives you an interesting perspective on the data. Well, what if you filter out all the unrestricted? These are the ones that you have left where the connections are coming from that you might want to pay a little more attention to. We do have offices in Brazil, we have offices in China, we have people in India, we have people in South Korea. So it's not necessarily a bad thing, it's just you might want to pay more attention to make sure that you don't have any surprises along the way. Your business policy will define what you want to do with it. But now you have a discussion based on data that's real life, as opposed to, we think this might be a bad idea. And again, you can see Syria poking its nose in the bottom there. Same data glitch. So picking on China a little bit, what about travelers? We have these people, and you see the count of the username, they're actually in China, they're based outside of China, that's what the columns are saying. But since we have offices there, we do have people traveling to China and coming back. If you read the newspapers and the various trade rags, you'll find that people go to China, are assumed to have a higher risk of being infected or having their machine looked at unexpectedly or bringing something nasty back. Do you need a policy around this? Business and technical. If so, what is it? But you can see now you have hard data to make that discussion and to actually show the point. And you can have now relevant discussion with the appropriate policymakers in legal, HR, InfoSec. Turning it the other way, what about the people in China that travel elsewhere to make sales? We have those too. So they're based in China and they're going other places to go talk to people on our networks as well as other people's. Do you need a business policy going both ways? It's a very interesting question. Your mileage will vary for your business, the countries or entities that represent a potential risk to you. But again, if you have the data, Now you can actually sift it out and figure out what it is you want to do as a business. So, changing subjects a little bit, we had this anecdotal problem where people are using VPN. We had our 3 major hubs. About a little percentage of the time, we couldn't tell you how much, people were connecting to the wrong place. For instance, our VP was sitting in Seattle in his house, and he was connecting to Europe for VPN. It's an automatic selection algorithm, but it's not selecting right. So we get this graph that kind of looks like Pac-Man run amok, but if you look, say, at the United States, a quarter of the connections are going anywhere else. That means a quarter of the connections being made are not going where we expect them to be. Now, the user can manually override this, and we can't tell if they did that or not, but 25% of the time, I don't think so. Look at Australia. Almost half are not going to Singapore, which is a group they're associated with for that data center. They're going to the US or to EMEA. And you can go around, there's too many slices here. You should be seeing pretty much monocolor for the group they're in. So we dug into the data a little bit more, and we actually picked the countries that the data centers are in. So this is the absolute best case. And you can tell they're not going to where they're supposed to be a good chunk of the time. We had some code fixes near the end of this chart that actually helped in North America, but looks like they actually may have not done so much in the EMEA area. So we dug into this some more, and it turns out we actually had a couple of bugs which have since been addressed, and we're actually adding GeoDNS-based networking into the middle of it, so it's where you go is based on the IP you're coming from as opposed to the best guess from the client. This is the test network that we've been running with it for the last couple of months. In the United States, we happen to have 2 data centers, so you see the red and the green, which is exactly where it should be going, one East Coast, one West Coast. If you look around Singapore, you'll see pretty much all nice blue spheres, though you do see some specific overrides in the Philippines for some people there that are doing work for us. They'd rather come this way. And in the United Kingdom, you see a few coming this way deliberately as well. But instead of Pac-Man running amok, they actually look like nice big dots, which is what we wanted it to do in the first place. By the way, we are rolling out this network corporate-wide right after this conference. It would have already been rolled out now, except that we'd rather not disturb anything while we're here. We want to make sure everybody can talk to you guys. So end results have been we are making changes to our business to help our customers work better. Okay, computer. And this is the last one before I wind it up, which is we want to take a look and there were a few folks that had some extremely high number of connections compared to everyone else, and this was a nice way to visualize it. So we went through, and those 4, yeah, turns out it looks like their clients are broken. They actually need help desk help to go fix their clients. So they've been living with the pain. They hadn't called in. We could have fixed it had we known about it, but they had never called in. Now we can go find them, and we can take care of their problem. And now, was that one of those big glitches at the end of the data? Yeah, one of those guys. It was just connect, fail, connect, fail, connect, fail, over and over and over and over. So now we can proactively help users that are having problems before they even know they necessarily had a problem. I'm a network guy. This is literally my first significant viz ever. This is what you're seeing at the end result. I know the data, but I build networks, I don't build business. It just turns out as a remarkably useful tool. We started that one simple question of where are VPNs coming from? Where are people calling from? And we found out all these other things as a side effect of having that data to look at it. And that's really the power. Now we can help our users. We can understand what some of the things have been going on we couldn't quantify. We can hold our vendors' feet to the fire because we can show them data that the stuff they claim is working wasn't quite working the way they had in mind. So it really, this is what we did. This is a man-month or so of my effort over about 6 months to gather and pull all this data together. It wouldn't have to be so hard, except I had to learn a whole lot along the way first. What could you do if you had this kind of power? That's what I leave you with. So, as usual, we have the proper slides saying, please fill out the survey if you like this presentation. We also have the slides of other things. The first one's already gone by, but the other 2 I highly recommend. And they're good sessions, and we'll leave this back up at the end. And again, I do apologize for a little bit of lagginess, but 3.4 million lines. We'd love to hear your feedback. If we're awful speakers, we'd love to know it. If you learned a whole bunch, we'd love to know it. Or both for that matter, we'd love to know it. And lastly, Q&A. We're here as long as you want us. Any questions you have, please feel free and come up. We're happy to talk to you, and the data will be shared. Thank you very much.